Okay, so our third test is on applications of derivatives. The first thing that we talked about was extrema on an interval. Those are problems where we were asked to find the absolute max or absolute min on those intervals. Remember, in those problems we would find the derivative, find out when that derivative is 0 or undefined. Those would give us our critical values. We would then look at those values that actually fall in the interval and then evaluate the function at those points and also at the endpoints to find the biggest value, which would be the max, the smallest, which would be the min. We then talked about Rolle's theorem and the mean value theorem. When we talked about Rolle's theorem and the mean value theorem, what we were looking at is to check the conditions to see if they apply. Remember, for Rolle's theorem, it has to be continuous and differentiable on the interval, and f of a and f of b, the two endpoints, have to both be the same. For the mean value theorem, it just had to be continuous and differentiable. So the questions on your exam will be asking, does it apply? And if it does, find the values it guarantees. Rolle's theorem guarantees that we'll have some point in the interval where the derivative is 0. The mean value theorem guarantees that you'll have some point in the interval where the slope of the tangent line, the derivative, is the same as the slope of the secant line, f of b minus f of a all over b minus a. We then moved on to talking about increasing and decreasing. For these problems, we found the derivative, determined when it was 0 or undefined. We then plotted those on a number line and evaluated the derivative at each of the intervals. And then that would give us the sign of the derivative, which would then tell us when it's increasing and decreasing. We could then use that to figure out any relative extrema. Okay, remember, relative extrema will be points on the graph, so once you've decided that a certain x value is a relative max or min, you'd evaluate the function to get the y value. 3.4, we talked about concavity and points of inflection. Here we would find the second derivative, determine when that's 0 or undefined. Those would give us our key points, which we would then plot on the number line, evaluate the second derivative, determine when it's concave up or concave down, and then points on the graph where the concavity switches are called inflection points. And again, much like the problems in 3.1 and 3.3, you'll then evaluate the function to get those points of inflection. It'll be an XY pair. So those problems in 3.1, 3.3, and 3.2 are very similar. So you really got to keep in mind what it is you're trying to do in each of those problems. We then moved on and looked at limits at infinity. So when was the function, what the function doing as x approaches infinity? And so we looked at how to evaluate those limits. And so you'll have some questions dealing with that. And then finally, we talked about optimization. You can expect probably 2 questions on optimization on your test, very much like some of the examples we did in class or the video examples that you have posted for you to look at. So that's your test for Chapter 3. Good luck. If you have any questions, send them my way.